in a table, and I think haven't I talked about something being skewed with you guys already? Haven't I done that? I think I have.
Just a bit on the last graph that we did where it was on the backside of the reader where you said there's a gap on it. I think you talked about it a little bit.
Okay, that's picture is an illustration of something being skewed. That picture is something being symmetric. We always talk about it being tailed. So there's a little tail on the right-hand side. It's called the right tail skewed or right skewed. That's symmetric. Symmetric meaning, like a mirror image, like a parabola in your algebra class. That's very symmetric. So, and shape, like, oh, that looks like a bell. We always talk about, and you've heard about bell-shaped curve.
Bell-shaped curve.
Yeah. And you might even hear, and maybe even one of your instructors that you have so far will make this statement or claim, I grade on a curve. You might say then, after this class, say, well, tell me, Professor, whoever it is, describe to me what you mean by curve. A statistical curve would be one that looks like a bell-shaped curve. They call it normal. And I'm going to show you, based on your first exam results, I'm going to show you what the spread or the distribution looks like with our first exam, and look and talk about what it should look like if I graded truly on a curve versus what yours looks like. I don't grade on a curve. I don't. And other instructors might say, you tell them what you've learned in a stat class, and oh no, I don't grade on that kind of curve. Well, theirs is not then a truly statistical curve. So later on, probably, I don't know, maybe even after these two sections, definitely by Monday of next week, and then we'll talk about what that means. Then I'll use the data from our exams to demonstrate that later on too. So anyway, skew right, and there's a skew left, that's just the reflection of this, and that's symmetric. Now, these are two-digit data. This is easier. I'd probably only ask you this on the test, because when it gets to be 3 digits, what's called stem and leaf, you have to make a choice whether the stem, how many digits of the stem, and that determines how many digits are the leaf. I'll tell you what I mean by that. With 2 digits, one of the digits is the stem and one's the leaf. Easy. And for us, the stem is going to be the tens digit. So if I did this thing, it's called unordered. If I did a tens digit, this is called stem. And this is called the leaf or the leaves. And then eventually you want it to be ordered. So the way I do the stem and leaf, there's not a lot of data right here, but what I'll do is go, I read from left to right, top to bottom. That's how I read. I say that because there's now a lot of books now. I think different cultures will read, I call it backwards, but they might not. They start from the back of the book and read, I call it backwards. But here I read, I'm gonna go this way. Now, it looks like it's already in order. You see that? You see that? So maybe just to be weird, I'm gonna be weird. I'm gonna read this way, so that I can show you what an unordered might look like. Because this is already ordered, I would go directly to this. I wouldn't have to do this, but just to show you, if all the numbers were all jumbled up. You know how your colors that you guys gave me last time, they're all jumbled up. They weren't in any order. I just randomly grabbed them. Then I'm gonna go this way. And what I'm gonna look at is stems. What digits are the stems? Well, I see a 3 and I see a 2 and I see a 1. I see 30s, 20s, and teens. Are there any 40s? Oh, and I also have a couple single digits. So what's the tens place on these two?
Would be
What,
0.
right. So I'm going to do the stem from either, it's your choice, 0 to 3 or from 3 to 0. So either ascending or descending, doesn't matter which one. So I'll go ahead and do it ascending. That means I'm going to go from 0, and these are the teens, and these are the 20s, and these are the 30s. And the leaves are the ones digits. So as I was saying that if you had numbers that went into triple digits, then you're going to have to make a decision on how to order this in a stem and leaf. To be honest with you, I don't know if it's really used all that much anymore. I still throw it in once in a while just to have something extra. So the problems you're going to get are just going to be double digits, just like mine, if I give you one on the test. So I'm going to go 37. Now I'm going to go down here. Oh, that's the 30s. So just stick the 7 right there. That's and the way you read this, it's 37. 37. And then do the 21, 16. Okay, 33. That's down here. So that is not 373. That's 37, 33. If you prefer, you can put a comma in between if it helps you. I'm okay with that. So you know that there's really two numbers here. There's two leaves, so there's two numbers. Sometimes the book will have a little space in between each number, so you know that differentiates it from different numbers. So I'll put commas. Okay, 21 and 15 and 33, 21 and 14, 32, 20, 14. Oh, silly me. White out. Left it back at my other house. Well, my other house is an RV. Sold our home. Sold our home. We moved. I don't know if I told you that. So now we're living in a trailer for a year. My choice. That's okay. Oh, I think I'm. Where am I? Right here. Shoot. Yeah, right here. So let's see. 28. Maybe 19 is here. 12. And then 23, 18. Oh, the number 9, so that goes over here. 22, 18. Oh, 6. 22, 18, 22, 18. So if I did it right, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 3 is 27, and 4 more should be 31. Let's see if I got 31. Okay, there's 2, 4, 6, 8, 10, 12, 14, 15, 16, 18, 20, 22, 24, 26, 27, 28, 31. Okay, looks like I got them all. Got them all. Now, this is not ordered. Ordered means you're going to go smaller to bigger or bigger to smaller. So this is the number 9, that's the number 6. No, I want the number 6 first and then 9. So I want them in order. I'm going to go over here. I don't know if I'm going to run out of room here. This would be 0, 1, 2, 3. This is leaf. Okay, so this would be 6 and 9. I'm going to put the 2's first. 4 is next. 5, 6, 8's. Looks like 4 8's and a couple 9's. All right, 2, 4, 6, 8, 10, 12, 13. 2, 4, 6, 8, 10, 12, 13. Okay, I got all the numbers there. After 19 comes 20. Okay, so I got a couple of zeros there. And then 1, 2, 3. 1, 2, 3. 3. A couple 8's and a 9. And finally, here would be 32 would be next, 33, 33, and 37. I won't put commas in between because I think you get the idea that they're separate numbers. All right, now that creates the plot. That's all there is. Now here's what sometimes it would be helpful if I turned it this way. And thought this is a number line. So here's the zeros, smaller to bigger on the number line, like that's the origin there. This might be interpreted maybe a little symmetric, maybe, ish. Not exactly, but so someone might say, hey, what's the distribution look like? Skewed or symmetric? Now, it looks more symmetric than skewed if I were going to choose. Here's another question that could be posed. I don't know what this has to do with anything in terms of real data. Maybe it does up here. Oh, here it is. Number of touchdown passes thrown by each team of the National Football League. Okay. Then they could say how many passes or how many teams threw more than 19 touchdown passes. More than. Now, if I write more than, in the back of your book, I have those phrases too. The symbol for more than is that. It does not include the equal. It doesn't have equal. So you're going to have to get familiar with this in the semester. The English language words and the symbolic notation, and does it include equal or not to get the right answer. So I don't include, I said more than 19. Didn't I say more than 19? I think I said that. So I go down here and it'll be pretty easy to answer this. More than 19. Okay, there's 19, but more than, hey, that's all of these guys. So then just count the leaves. 2, 4, 6, 8, 10, 12, 14, 16. Okay, there were 16 teams that had quarterback touchdowns more than whatever it was. 19 touchdowns. So more than, fewer than, at most, at least. You'll see those posed based on a stem and leaf. And if you got it ordered, now this is already ordered, so this would be easy to do as well. Most of the time, like on the exam, I'm going to mix it all up. So it'll be challenging, not impossible, but challenging if you didn't kind of create an order to it. Wasn't the baseball player home runs, wasn't that ordered for you nicely? I did, that was nice of me. It would take me a lot longer and harder if they were all mixed up. So be prepared on the exam. Probably it's going to be mixed up. May not be 49 data values, but they'll be mixed up. Okay, well that wraps up chapter 2 then. This is what people were saying, right, about the misleading graphs. There are some of these. Oh, here's the one I grabbed off the internet. Same one right there. And so on. Huh, that's a duplicate. Oh, how funny. These two. Oh, actually, it's not. This has got an extra graph on here. But I think all the words were duplicates. And this might be interesting for you to, I found this on the internet, for you to watch. Here's a link for the YouTube video. I watched that, says, oh, that's actually pretty cool, because it'll talk about misleading graphs. Excuse me, if you're interested in seeing that. So you can do that on your own. Okay. If there's time today after class, hey, I got a little extra time, I might go back to that YouTube link and we'll just watch it together for a little bit. Little commercial break for a second. I have a former student who's an instructor as well on campus. When I say former student, he took my statistics class. So he is now he's really, talk about somebody who could be really helpful for you. He can be. He's working now for the College Skills Doyle. He just sent me an email. So I asked him if he'd be available to come to this class on Monday next week, just to introduce himself and tell you guys about how to access him, ask for him, because he's had my exact class. He'd be a great resource for you. And so I think on Monday, if he gets back to me on email today, you'll have a guest coming in. His name is Angel, really very good. So, okay, now, chapter 3 is all about measures. I think there's 4 sections. There's 5 sections altogether, and I skip one of them, if I'm not mistaken. 3.1, 3.2 is what we're going to do today. Measures of center is the first one, center. And there are 3 of them. 3, count them 3. 1, 2, 3. 2 out of the 3 are used a lot. And 1 in particular is used a ton. So there's 3 measures. You got mean, median, mode. These 2 are used a lot in real life. I've yet to find, this is kind of boring anyway. I'll tell you what the definition is at the end. So I don't see this used a lot. These 2, a lot, and that's a ton right there, mean. So the mean, if someone ever said, or you heard the word, hey, what's your average? What's your average grade point average? Well, what's your grade point average? That's the one that everybody usually remembers, because it's basically adding up all your grade points and divide by how many classes you have. Or like, what's the average age in this class? You would think, rightfully so, I understand, you would add up everybody's age and divide by 29 people if we have 29 people. That's called the arithmetic average, arithmetic mean. Arithmetic. So if you look at, it says the mean, and there is a symbol. Now comes the, it's a little blurry there. Let's see. Whoop, there. Okay, now comes the first of many symbols in this section. Letters, sometimes it's letters. It's this symbol is the first one, and that's the second one right there. Okay, so the mean is, you usually come up with, you add them all up and divide by the number of the data values. So X bar is for the sample, and that's pronounced mu. M-U is how you spell it, M-U. It's a Greek letter, Greek letter of the alphabet, and it's actually lowercase. Greeks have uppercase and lowercase. My trig class, they learn all about it because we use almost exclusively for variables, Greek letters of the alphabet. It'll sound like a sorority or a fraternity. Alpha, beta, gamma, theta, pi is a letter. Phi, fo, fum. No, there's no phi, fo, fum. Phi is, yeah. Sigma, oh, you're going to learn about sigma in this course. Yep, there's another Greek letter of the alphabet coming. Anyway, X bar is not Greek. That's how you say it. X, this little bar up there. And it's lowercase, not uppercase for us. That's for sample. Mu is for population. They're both means. So one's a sample, one's a population. You're going to have that throughout the semester. One's for the population, which means all of it, which rarely happens anyway. And one's for sample, which is where you could make, unbeknownst to you, but you are aware of it, you could make an error. I'll say that again. If I want to know what the average age of every American is right at this moment in time, that's including kids and grandparents, you know, people are dying and being born the whole time. Okay, take a snapshot. 360,450,300 people. Okay, you would take all their ages and divide by that number. That's the population. That would be mu. But that's almost absurd. It's not going to happen. So what you do is you take a random representative sample. And you got 5 sampling techniques that we learned. And then X bar would be that result, and you know that there's going to be an error because that's not exactly what the American, all Americans average age is. But it'll be pretty close. Probably, maybe. Later on, we'll find out how close. Okay, how many numbers we got? 2, 4, 6, 8. 8 numbers. Okay, divide by 8, add them all up, get a number 6. Easy, right? Easy. Your calculator has a way of doing this as well, instead of you going like 2 plus 5 plus 5. So I'm going to show you today how to use your calculator, because this is not difficult to do. I mean, if I had 49 data values like the baseball, I'd still have to type these in somewhere. I don't think I've got a scanner that will take it and dump it into the calculator. I don't know of that. So you'd still have to type the number in, but you're going to get a lot more results besides X bar. You're going to get a lot more results that are going to be helpful down the road. And I'll show you what those look like today. Matter of fact, I'm going to show you what it looks like right now. Here's the instructions. Now, there are, let's see, I can think of 4 different places for your calculator instructions most of the time. 4 different places. It's almost impossible for you to get stuck. Like Jan says, I don't have my 84. Yeah, well, maybe not today, but tonight she's going to say, well, how do we do that X bar thing? She's going to Google it under Texas TI-84. How do you do the mean with the TI-84? You Google it, look at the videos, YouTube videos. You look at my page here. You look at textbook page 117. It's got another place there. And the back of my packet has them all. The back of my packet has, I think, virtually every calculator keystroke that we're going to do. It's just before what I call the tables in your book. So here's your these are called tables right here. So it's just before that, and it's just after the definitions in your back of your packet. So here's something here. Here's something. Well, I'm going to do number 2 today, right here. I'm going to do this today. That's Roman numerals. So instead of Greeks, I'm saying Roman numerals. Oh, here's something else I'm going to do right here. Roman numeral 3. I'm going to do number 3 today. The mean. I'm going to show you how to do the mean. But you can also find the median and the standard deviation doing this keystroke here. And you got others in there too. So I'm just going to look at what I've got down here. And then take my calculator. So I have to hold it up like this. All right. Turn it this way. Turn it this way. And don't have enough desk to lay this out on. Okay, how do I do this? Okay, that's fine. You guys are in my way. Looking at my screen, sorry. Okay, close. I think as long as my calculator doesn't fall on the floor. Well, okay, turn on the darn calculator. Blank, blank, blank. Okay, we're going to enter data and we're going to use the one var stat. So let's see. I got to show you how to enter the data. Shoot, that doesn't. Where's my other? Oh, over here. I had the wrong page. Silly me. Silly me. Okay, we're going to press the stat button right here. Stat button. All right, so the stat button's right there. Okay, who doesn't have this on their screen right now? I'm going to take it in baby steps. Anybody not have this on the screen? Okay. The next thing is, I think I have edit. You see where it says edit right here? So the top, you see where it says edit right there? And there's edit right here. Okay, so you're going to press that right there. Well, just press enter. When I say press it, there's an enter button down here. Now, because I've used my calculator in stat classes, I got junk in there right now. And some of you may have gotten your calculator from somebody else and there's stuff in there too. So I'm going to show you how to clear out junk. If you don't have something in, okay, first of all, who doesn't have list one to begin with? Now, that's important. And let me stop screen. I got to see show of hands. Who does not have list one at the top of their screen? I got to see who does not. 83 calculators just works exactly the same way. Okay, Pratima, what's your first?
I don't have a calculator yet, Professor.
Okay, so you and Jan are just going to have to watch this later on.
Okay.
If you've got a TI-84, 83, and you press the stat button and then edit, who does not have list one as the first one? Who does not? Okay, good. So I'm going to go back to the screen here. That means everybody does. What I'd like you to do is, if you don't have something in here, just type a couple numbers in. Yeah, I don't care what's in there. Just type in like 99. You know, just type in whatever you want, only in the first list. Just let's say 2 numbers. I don't care. All right, now I'm going to show you how to get rid of all the numbers. The fastest way to do it. Well, at least the one I know how. Okay, toggle. This is my toggle. Toggle up until the dark cursor is on L1. Who doesn't have the dark cursor on L1 just like that? Who does not have it? Just unmute your microphone and says, Jeff, I don't have that. Okay, there's a clear button right here. Press it once. Okay, I'm going to press mine. Pressing it does not make it go away. What you have to do after pressing it once, you have to hit the enter button right after. So press the clear and then enter, and it should all go away. Okay, I'm going to stop my share and see who doesn't have their columns clear. Who doesn't have all their columns clear? Good, you all do. Good, good. All right, now, some of you may say, Jeff, I don't have list 2. Well, don't worry about it. Right now, you don't need list 2. You won't need list 2 until the end of the semester. And then ask me that, Jeff, I can't find a list 2. What's important is a list 1. On occasions, some of you are going to lose list 1 on occasions, and ask me why that happens. I have no clue. If you ever lose list 1, then reach out to me and or Google, how do I get my list back in my TI-84, you know, and see what the YouTube video has. But reach out to me and I'll tell you the keystrokes to get it back. So I'll say it one more time. if you ever lose list 1, if that's gone, and let's say it starts with list 2, you need list 1, then reach out to me and I'll tell you how to get it back. Okay, so now I'm going back down here, and this says, what does it say? All right, you're going to enter your data in list 1. Oh, what's the data? Oh, right here. You're going to enter 1, 2, 3, 4, 5, 6, 7. You're going to enter 8 numbers, those 8 numbers, in that order they have. You don't have to arrange them in order, into list 1. Okay, so I'm just going to literally do that. Okay, here we go. 2, and you hit enter after you do that, by the way. Okay, and then 5, enter, and so on. We get down to the last one. See how it says L1 means list 1 has, this is the 8th position, and that's the 8th number, but I don't see 8 up here yet until you hit enter. You have to hit enter after you do each one. Okay, now we're done. Oh, but Jeff, there's the 9th. Yeah, but there's no 9th number. There's only 8. See up here? There's only 8 of them. Okay. Now, there's some instruction in here you don't need to do. It turns out where it says frequency is 1, you don't need to do that. It's now determined that if you see nothing in here, the default is 1. You can put a 1 in there, but it's extra work. It's busy work. So there's invisible ones in here until you tell the calculator differently. So that means I put in 1, 5, I put in 1, 7, I put in 1, 8, I put another 1, 1, 8. Each of these are individually put in. I could, to do that, you don't do this, watch though. I could put in 2 and then go over to list 2 and say, well, how many 2s do I have? I only have 1, 2. Oh, okay, then put in the number 1 here. And then go over to the next, okay, 5. Well, how many 5s do I have? Well, I have 1, 2, 3. Then you can put frequency, 3 5s. I don't do that. I just put them in, even 49 data values. I make them all frequency 1. That's what I do. It's just faster, easier. So I don't use the list 2 for frequencies. Leave it blank. Clear that out. Clear that out. Put it back in, I guess. Yeah, so scratch that off. Okay, the next thing is you want to do second quit. Second quit, so right here. So there's a second button right over here. Now the quit turns out to be right there where the mode key is, right here. There's blue. It's hard for you to see. I can see it right there. So I want to press the mode key to get the quit. And basically you want to clear home screen. You want to get back to where there's nothing on your screen. Basically you're going to start all over again. Okay, so start all over again. Hit the stat button. Who's not with me, by the way? Who doesn't have a clear home screen? Okay, hit the stat button. I want to go to calc. That's my next set of instructions. Go to calc. That means I toggled over to calc. And I want the 1 var stat. I want, the very first thing is 1 var stat. I want that. So now you hit enter and stop. It says hit enter twice, but just hit it once, and stop for a second. Hit enter once. Now, my calculator will look different than some of yours. Some of yours won't look like this. Mine's an upgraded 84 version. Some of you have an old 84. You didn't know that. You bought it brand new, but it won't look like that. And I'm going to see how many people have an 83. I'm going to stop my share. Okay. Who's got an 83? Raise your hand. Just keep it up. Okay. Dasha does. Let's see who else. Anybody else Just Dasha? Okay, Dasha, your calculator screen looks different, right?
Not that much different.
But it doesn't have this list one frequency list, and it doesn't have that, does it?
It has like the list one.
But it doesn't have this other frequency thing, does it?
No.
Does it have the word list right there with snake bite?
No.
Right, so hers looks different. Who's got an 84 that doesn't look like this? Raise your hand. Who's got a TI-84 that doesn't look like that on the screen? I'm going to scroll over my other screen, see if anybody else. Okay, Dasha, you're the only one, but you can, this will work. It's not hard. So wait just a second, okay? You hang in there. Everybody else, what you're going to do is see where the cursor is, right? Well, you don't see that. Of course you don't. I have to share my screen. You see where the blinker is right here? Okay, just hit enter. This is a good thing, want list one, or you guess you can toggle as well. You can either enter or toggle. Okay, frequency list. Yeah, leave it blank. Basically, you're not touching anything. Don't put anything in. Okay, go down, toggle again, go down to calculate. And then hit enter and stop. Hit enter and stop. And now you got all this stuff. Okay, Dasha, what you'll have to do is hit enter one more time, and if I'm not mistaken, you'll get what I have. Tell me if you don't, Dasha.
Yes, it looks exactly like that.
Fantastic. So who does not have all this stuff right now? I'm going to stop my screen. I want to make sure everybody has the same thing as I do. Who doesn't have, if you've got a calculator, does not have this? Okay, nobody's saying anything. That means you all good. I'm taking it slow enough. That's a good thing. Now, when I look at the screen, the calculator screen, okay, here's the X bar right there. And we already knew that by hand, but at least the calculator agrees. How many of you have ever seen that funny little symbol right there? I see Emily. Have you ever seen that funny little symbol right there? Yes or no? Nope. Brianna, have you ever seen that funny, it looks like a funny E. Anybody? Brianna, have you ever seen that funny little symbol ever?
Sigma?
Nope. Okay, who said that? I'm curious. Just say your name because you're not coming up on my screen. Dustin?
Jonathan.
Jonathan, thank you. You're right, that's sigma. So I'm going to put my calculator down here, and all of you, okay, at the beginning of the semester, I said all of you should have had an intermediate algebra class before joining this class. You should have. And should you have had your intermediate algebra class here at SRJC, every single instructor goes over that symbol. So yes, you have. You just either forgotten or chose not to learn it, or never learned it, never got it, or dropped the class or something. So I hold all of you responsible for saying yes, basically. Except maybe there's a high school class, or maybe you came from another college, and you took your intermediate algebra class there and they never covered it, so then that's a possibility. That's called sigma. This is capital sigma. I don't have to write the word capital, but I will. Capital letter. Again, it's another Greek letter of the alphabet. There is going to be another sigma coming up today. It's the lowercase letter, and it means or represents something completely different than what this is telling you to do. So Jonathan, do you remember what that means or tells you what to do?
No, not at the moment, sorry.
That's fine. Okay, anybody who might have said, oh yeah, Jonathan said, I know now. Anybody remember anything about sigma?
Isn't it the sum of?
Right, whoever said, oh, that was Natalie. Right, thank you. So this means summation notation. That's another way of saying it, summation notation. I'm going to show you something in the back of your packet. There are symbols. You're held responsible for knowing every one of these symbols and how to draw them. And you're held responsible for knowing the formal definition, my definition, not anybody else's. See, there it is right there. Number 3. You have to know what the formal definition of that is. And the answer is on the next page, right over, number 3. Summation notation. Don't say sigma. If you say sigma, you're going to be wrong because there's 2 sigmas. And I don't know which one you're talking about. So this one here has to be summation. If you just say summation, that's not good enough. If you said sum as or sum of, it's not good enough. It has to be word for word summation. No, it doesn't have to be capitalized notation. On occasions, rare occasions, I'll put on your multiple choice version, pick the right symbol for summation notation. And I'll give you 5 symbols and you choose the right one. Or I'll say, pick the correct formal definition for that symbol. And that would be the correct one, not sum, not sum of, or not sigma. And then that'll be a multiple choice kind of question. So every symbol, how many symbols? Gosh, I got 41 that I can give you on a test, on any test, 41 symbols. And they're all important. There's a lot more than 41. I just stopped at 41 because I ran out of room. Okay, go back to the calculator now. I'm gonna go back over here, turn that on. Now that's going to be an important one, the first one. The next 2 aren't important for what we're going to do for those numbers. I'll usually never use those 2 numbers, but I want to know what the summation means because I'll use that symbol later on, but not that number, not that number. Okay, the next one is an S. Now you want to make note in your notes, in your calculator. So I'll say this again, make a note somewhere, write it down on your paper, that in your calculator, that S is a lowercase s. It's not an uppercase s. It looks upper, but it's not supposed to be. All right, that's a lowercase s. Okay, make note of that. That next one down there looks like a funny little upside down sideways A. See that right there? Then that is sigma as well. That's a sigma. That's a different sigma. And we'll learn about that symbol here shortly. Okay, that tells you how many data values you have. That tells you that's the lowest one, minimum's the lowest one. We'll talk about quartiles, I don't think today. We'll talk about it on Monday. Okay, median we're going to talk about right now, the next one. We're not going to talk about that one today. And max means the very biggest number that you have in there. So that's just information. Okay, let's see. Now, the median. Okay, that's next right here. The median is the middle number. It's the middle number, but you got to arrange it in ascending order. Let's see if I've still got it here. Give me a second. I might have an article from the newspaper Sunday. Nope. Nope. Let's see. Yep. Good. Saved it. So look, this is on Sundays. Median home prices. The real estate company always uses median as their average, not the mean. The reason why they use the median is because if we call this median is not sensitive to extreme values. Median, and that's in your textbook too. The median is not sensitive to extreme values. The mean is. So home prices, you know it's ridiculous in Sonoma County. I mean, you can look at here. Oh my gosh, Sonoma Coast. Look at $1 million is the median average, and last year 790. So it's gone up a lot. Healdsburg, ridiculous. Of course, you got to look at how many sales. 32, ridiculous, awful, ridiculous. Now, if there's 32 data values, the middle one, this is what it's saying, the middle one is 1,100,000. That means there's let's say 15 homes that sold higher than that, and there's 15 homes or 16 homes that sold lower than that. It's the middle one. If one more home sold that was like $100,000, all that would mean for the middle is it shifts over one more value. So it wouldn't, the median doesn't make a difference much. But if it was the mean, you're adding $100 million and dividing by 33. Whoa, it looks like that the average is really like $50 million for an average mean price of a home. That skews probably the reality out there. So the realtors like to use the median, and they always do. So that's one place I always find the median. But for you guys, you got to arrange in an order and then pick the middle one. So here we go. This is not an order, so you're going to go 2, 5, 5, 5, 7, 8, 8. Okay, I'm just going to count like this. This is the middle one. I know for a fact there's going to be a couple of you that don't get it, or you're not paying attention, or maybe you're not even here today, meaning not you guys. Somebody didn't show up. And they're going to know that there's something about the middle one, and this is going to be out of order on the test. They're going to pick 7. They're going to say median is 7. It's wrong. Median is 5. So hopefully it's not you that are here today. All right, what about this one? Okay, I'm going to go arrange this 2 and then 5 and 5 and another 5 and 7 and 3/8. Okay, now I'm going to count them up. So let's see. Hey, there's 2 middle numbers. So if there's an even number of data values, what we do according to the instructions up here, if it's an even number of data values, you're going to average the middle 2. See, the median is not sensitive to extreme values. So what I'm going to do is I'm going to take 5 and 7, add them together and divide by 2, 6. Okay, how did you get that, Jeff? 5 plus 7 divided by 2 is equal to 6. This is your median. Median. You got to arrange it in order. You don't have to arrange it in order if you don't want to for the mean. In our calculator, the median, which is the middle number, turned out to be right there at number 6, the last problem. Not this one, but the last problem I put in there. Okay, and that leads me to the mode. The mode is the easiest because it's just the most frequently or most occurring data value. All right, it's easy. Okay, let's see. Okay, it's 5. Mode is 5. Mode. Because there's 3 5s. That's the most. Down here, let's see. Okay, there's 3 5s, 3 8s. So the mode, there's 2 of them. Mode equals 5 and 8. Like 5 and 8. So we call it bimodal because there's 2 of them, bimodal. Or multimodal, sometimes we would say. It's not very interesting. It's boring. If I gave you anything, I might not even give you one of these, but if I gave you one, it'll only be 1 on the test. That's it. Too easy. Okay, I don't have time today because I've got to scoot through. I'm still not even 3.2 yet. If I were asking find the mean and the median, you just add them all up and divide by, let's see, 2, 4, 6, 8, 10, 12, 14, 15. If you wanted the median, it's the middle one. So it's probably DeMarcus Cousins when he was there. Let's see, 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6, 7. No, it's Jonas right there. That's the median. Because I think these are in order. Yeah, these are all in order. If they asked, okay, here's how this works. If they ask one more player to join their team, let's say they asked LeBron James, and they paid him, and let's say his salary was $100 million, $100 million, okay. Well, the median would just go up by one more, or since there were two, it's just be the average of these two. The median would be about $3 million. But if you did the mean, you'd have to add 100 million and divide by 16, and the mean is like, whoa, my gosh, it might be like $80 million. So that's why the median is not sensitive to extreme values. Oh, and we've seen these before, right? This is a left tail and a right tail, left tail, left tail. Okay. More pictures about skewness. Okay, so this is a right tail, left tail, and that's symmetric. Okay, the nice thing about symmetric or symmetry, the bell-shaped curve, is that the mean, median, and mode is right there smack dab in the middle. Think about this as a frequency. This is the highest, so the most, that's the mode, is right here. And if you listed all your data values from smaller to bigger, the median would have to be right there in the middle. And it turns out if you add up all the data values, it'll be right there in the middle as well. I just kept these articles over the course of time. You could look at, what year was this? 1999. The median was, yeah, well, that was a long time ago. $250,000 was the middle price of homes in Sonoma County. Yeah, what did I say it was? Oh, I don't know. Let's see what Sonoma County is right now. Sonoma County. 720,000. Oh, that's $500,000 difference in a course of what? 10 years? 20 years? Almost 20 years. 1999, 2000. Yeah, 20 years, 21 years. I just have more, and you can see how it keeps going up. We were like, oh my gosh, what's happening to the home prices? Things are going crazy. What is happening in Sonoma County? Things are hot. It's hot. 430. Oh my gosh. 500,000. This is 2005. 2005. All the way up to 615,000. You know what happened in 2006-07? Yeah, somebody's shaking your head. You might have lived through it or been born then. Yeah. The big housing crisis, which kind of also correlated to the Great Recession. Yeah, then all of a sudden, this price plummeted down to about 300,000 that next year, average, median. Well, now we're back up after, what was that, 13 years ago, back up again. This one here is just another one. You can see words that are about them, like up here. Okay, I'll start right here. NBA players have the highest average salary. Okay, now you guys, how many averages did I go over today so far? 1, 2, or 3? There's your choice. Pick one of those. How many different averages, definitions did I do? Natalie, hold up fingers for me. Thank you. Brianna, hold up fingers for me. 1, 2, or 3? Got to pick. 1, 2, or 3? Brianna, I might have said Natalie. Brianna, okay, 2? Was that 2? Peace. Okay, she says 2. Emily, 1, 2, or 3. You 2. Okay, Ananyali. Gosh, I said that. Ramirez, Miss Ramirez. 1, 2, or 3. 2. Okay, Natalie's the only one that got it right. There are 3. So Natalie gets an A, and the rest of you get Fs. No, I'm just kidding. I'm just messing with you. Okay, so Natalie, tell me since you got them right, give me all 3 of them to keep your A.
We had mean, arithmetic, like the mean for, I believe for is it for like samples and?
Yeah, just say mean. Just say the mean.
Okay, just mean, and then average, and then arithmetic, right?
Okay, now you're down to a B.
Okay.
Sorry. Rats.
Sorry.
Okay, someone give me the 3. There are 3. Someone else give me the 3. I'll give you a little hint. M&Ms. Give me the 3 M&Ms. Yeah,
You
go
just
ahead, Jan.
mean
Go ahead, Jan. You're muted.
Yes. Mean, median, and mode.
There you go. There's the M&Ms. Mean, median, and mode. Okay, that's the 3. So I've given you 3 of them. What are they talking about here? It says average. There's 3 average. Which one? Well,
Median.
let's see. I think it's the mean, probably, because see how they're talking about the median right here already? So they say
Okay.
their average is 2.6 million, and the median is about 1.3. There's nothing about mode here. They usually don't use mode. I think they're talking about the mean. I'm pretty sure. All right, NFL make about $900,000 for the mean, and Major League Baseball pays an average of, it looks like over here, 1.45 million as of whatever this date. I don't know. I don't know how long ago this was. Honestly, I don't. So it might have changed since then. I mean, NFL might be paying more than NBA. I don't know. Okay, almost done here. I'll let you, okay, and then I have gas prices, and you know where gas prices are. I came from Tennessee over the summer. Gas prices there are $1.65. California has the worst. We make the gas, we ship it to other people, and we we pay the worst, the most taxes and everything. Yep. Okay, now the last section here, it won't take me very long. Standard deviation, variance, and range. Oop, can't see that. Great, there it is. Standard deviation, variance, and range. What's a deviation? How far something is from something else. It's like how far does something deviate from, let's say, the center. So if I don't know, there's my center right there, red pen. How far away is the blue pen? You say, well, measure the distance. Yeah, I know. Okay, how far away is the blue pen from here? Well, it's less, but for you guys, that's on the left-hand side of this. That could be negative, where this one's positive. You're going to learn that maybe today. If not today, it'll be Monday. So if you're on the left-hand side of, we call it the middle, mean, median, mode, then it could be negative, and then on the right-hand side it'd be positive. So let's say the average class age of class is 25. Somebody's age is 19. Then they're off in the negative direction by 6 years. And someone who's older, they're off by 1 year from the average. Excuse me, that's positive one. All right, crazy formulas. All right, here's a good thing that you could say thank you to. You have no idea why you're saying thank you, but I'm telling you right now, if we were in a classroom, you would be using these formulas because I'd want to see pencil, paper, process is more important than the answer. So I'm looking for process, but I want to give partial credit too. Well, we're not in the classroom. So this is why I'm saying thank you. You don't have to ever use the formulas. You just know that they exist if you're on a deserted island and you have no calculator.
Would you want us to use them on the homework?
No, you don't need to. You're going to use a calculator. You see that symbol right there? Remember me pointing that out to you in the calculator? Yes. Okay, that's in the calculator too. Here it is. Yeah, well, there's the S right there. Remember I said that's lowercase. You had to write that on your notes. And there's the other one. That's the sigma. So for this one, there it is, and there it is. Okay, there they are. So it's embedded in your calculator. So it just gives it to you. You don't have to work it out. Okay, other symbols right here. Make sure you understand. X is the particular data value. X bar is a sample mean. Mu is the population mean. All these definitions that are in the back of your packet. Little n is sample size. Capital N is population size. And that symbol is summation notation. We're not going to do these by hand. No, no, no. So if it asks you in your homework, which will say calculate the standard deviation, get it right off your calculator. You have to input the raw data like you would do here, and you do the calculator keystrokes, and it will be there. It'll be there. So I'm not even going to do these guys.
So this raw data that you're talking about, we're not going to do right now. This is going to
No.
be, so we're not doing it at all, or is it the same process that we did in the beginning?
Same process.
Thank you.
You're welcome. Remember this? Stat. Edit.
Yeah.
Remember the data that's right here? I have 8 of these. Well, here you just have 5. Remember how to clear this out?
Yeah, L1, clear and enter.
Right, right. Remember, once you do that, you go second quit. The instruction is in my packet. And then you do stat again. And then you want to do calculate. And then that's the one you want. So you hit enter a couple times. Just keep doing it until you get to the end. Oh, there it is. And so everything's there for you. Everything's there. Nice. All right, now.
Yeah.
So I'm not, sorry, I'm not doing this. No, I'm not doing this because I've done enough for you that. I heard someone ask a question.
What did you say the lower case S stand for? I missed that.
Sample standard deviation. Here, I'm going to look in your, this is where you can find everything. Miss Ramirez, I'm going to show you right here. There it is right there. So you can put your answer over here, but guess what? The answer for number 6 is on the next page. Look at this. Their sample standard deviation. There it is. Now there is a capital S. That's why I'm saying there's a difference. If I go down here, see there's a capital S down here. That's different. Over here, number what, number 18? Yeah, see, it's called sample space. We're not even there today. Yeah, so just figure every single symbol. Yeah, I think every single symbol that I'm intending to show you is going to be on that back page. Ooh, I'm not doing this because it's just more stuff. I'm looking at time. I'm going to be sensitive to that. Okay, variance. Now, variance is similar to standard deviation. It's similar. For the most part, the rest of the semester, I never use variance. I'll ask you to calculate it without even using it. So it's just the number. Standard deviation, I use a ton. From here on out, it's used a lot, but not the variance. How to calculate the variance, though? It's, so for instance, it's the little s squared. That's called sample variance. So you square the standard deviation. Jeff, where do I find that? Well, look at my calculator, you will not see power 2. You won't see little s squared. No, that's not it. That's x squared. No. There's your little s. There is no little s squared on your calculator to be found. So what you have to do is you want to use the formula. You guys want to use the formula? Do you want to use the formula? Big nasty form. You want to see what the formula looks like? Here. You have two choices, calculator or the formula. Those are two choices. Yeah, you can use that. You can figure that out. That's a ton of work, by the way. You don't want to do that. S squared is that formula. You don't want to do that. You just use your calculator. Now, how to use your calculator, that's the question. If it's not even in the calculator, how do you do that? Then what you're going to do is you're going to take, let's say, little s on my last one. There it is right there. All the digits. Don't do any rounding. Don't go 2.1 and square that. No, no, no. Don't go 2.14. I mean, you'll get an okay approximation. No, you're going to write down every single one of those digits. Now, the reason why I say write it down, if you start typing right now, that'll all go away. You don't believe me? Okay, watch, I'll type. I'm going to type in, Jeff, 2. Oh, crap. Now what's going to happen? I don't remember it. See, so you can't just type. You have to write it down first, then square it. Here we go, back here. Okay, I'm going to write that down. So 2.1380899. I mean, it's like, well, that seems done. There's got to be a better way of doing that. Well, I don't know, maybe there's a better way. It's the only way that I can come up with. Now, I want to find s squared, or at least something close. So you're going to take all that and square it. So now I'm going to go ahead and type in 2.13. Okay, squiggle, squiggle. And now you say, well, Jeff, where do I round it to? More is better. You want a better approximation, yes. Do not round it to just 5. That's poor approximation. Usually we talk about 2 decimal places. So let's just agree 2 decimal places. 2, 2, 2. Every time, unless you're told differently. 2, 2. Always 2. All right, 1, 2, not that one. 1, 2. Okay, is that going to remain a 7, or is it going to go up to a 8, or going to go down to a 6? This is where I'm going to find out if you guys know your rounding rules or not.
Remain a 7.
How come? Whoever answered that, you're right.
Because the 1 isn't like bigger than 5, so we
Good.
keep it.
She's right. Good job. You remember that. So you keep that because that's not 5 or bigger. What do we mean, Jeff? Okay, go over here. 2. If I rounded here, do I go up to 3, down to 1, or keep it at 2? I go up to 3 because that next number is bigger than 5. So this would go up to 3, and the rest of these all stay the same. If you're having a hard time with your rounding, you better come talk to me, because some of the problems when you click your answer, they'll be so close. It's all about rounding and see if you know how to round. And you might know what you're doing, but you click the wrong answer because you rounded wrong. That's what it comes down to. So if you need help, ask me. Okay, go back here, here, here. Okay, the range, I think we've already done range. Didn't we do that with the width? Remember with histograms, I said, find the width. It's the range divided by the number of bars. We did that. Okay, range is 12, subtract 2, which is 10. I mean, very easy, very easy. Okay, this is a little obscure. I'm just going to give you the answers here and talk more about this, let's say Monday. Because this targets what's called the bell-shaped curve, the symmetric. This targets and talks about the bell-shaped curve. Your author also goes through a very colorful picture and demonstration about that. So I highly encourage you to read the author's version too. Oh, you guys remember SAT scores? I don't know if they're still around anymore. They might be changing them due to the COVID stuff too, but anyway, this is normal. It's called the normal curve. And we'll talk more about this, like your letter grades, your first test. We'll talk more about that. Okay, well, there you go. Oh, this last thing here, I'm not going to test you on it. It's interesting in statistics and probability, but I'm not going to work on this. All right, then I think I am finished. So, today there is no little quiz. No little quiz today. So I knew that. I'll stick around for questions for anybody on homework if you want. Other than that, the rest of you, you're free to leave because I have nothing else to say. So stick around, ask me questions, or have a good weekend, one or the other.
Hey, Jeff, I actually got a question on 2.2 whenever you're ready. On page number 79. Perfect. So for the homework, it was asking for number 17 for table 26. I was a little lost when it was asking to determine the class limits.
And there, yeah, so I know I look at this and I gave this one for the summer and I thought, well, maybe I can go over this and explain the difference between what I want you to do and what the author is telling you about class limits and boundaries. And even the notation, like it goes like less than 2, 1 to less than 2. It's like 1 up to 1.999999999. It kind of feels like, though, you remember my histograms, and you put like the number 1, let's see, number 1, number 2, number 3, number 4, number 5.
Yeah.
And if you had the number 2 anywhere, it would always go into the next pile.
To the right. Mm-hmm.
Yeah, that's why they do this. You're going to go from 1 up to 2, and then you go from 2 to 3 and 3 to 4 and 4 to 5 and so on. So that's what I'm looking at. And then the class limits. I'm not sure what the answer is. I'm looking to see the other things. Did I give you 18, by the way?
So yeah, for the homework on 2.2, you gave us 17 through 28.
I'm looking. Give me a second here. I'll look here. Let's do this. Those of you that are still here with me and you're curious about his question. Good question, though. You remember how I did it?
For
how many data values? Let's say this one here is for exports. How many data values for the exports? Not a lot, right?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my gosh. You might want to try the following. We normally said 5 to 20, right? 5 to 20?
Yes.
Okay, but there's so few right here. Even doing 5 wouldn't do very good. why don't you try like 3? Do it my way. So when I say 3, don't look at the back of the book, don't check the answers. So what I'm seeing is the lowest is what, 1.2, and the highest is about 5.6. Try 3, maybe 4 classes is kind of pushing it, but 3 to 4. And then what you can do, and then do the imports as a separate problem and the trade balance as the next separate problem. So let's say you do 3 or 4 classes, or I call them rectangles, and then find the width. So what you do is on exports, you would go 5.6 subtract 1.2. And let's say we do, I don't know, 3. I'm going to take my calculator. So I see 1.46666666. Okay, squiggle, squiggle. Now, if let's say you're going to make a histogram. Let's just do the histogram thing. Forget about the relative frequencies. Forget about the frequencies. Just want you to try focusing on a histogram, because that will be more interesting to me if you get the idea. The frequency and the relative frequency tables would come from raw data, or it'll come from words. Remember the Nevada counties? Remember the Nevada counties? Okay, it'll be something as simple as that. So let's say you use this data just to practice histograms, because that's where the classes are kind of leading you towards. What's the smallest number here? I think it was 1.2. Let's say you go squiggle, 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 put an arrow, make this 1.2. And now we want 3 bins, rectangles, piles, vials. Oh my gosh, bins. 3 bins. Okay, 3 bins. 1.2. Now, the width, I have to make a decision, because if I want 3 bins, there's 1 bin, there's 2 bins, there's 3 bins. That's it. That's as far as you can go. And you want to make sure that the number 5.6 sits over here, because the 1.2 will sit right there. So now this is a decision you have to make. What number would you like to make this, and try it? Because if it doesn't work, you'll have to tweak your width. What number, Enrique? And there's nothing that's a wrong answer. We'll just try it.
So when you're asking what number, what exactly do you?
I want the width. From 2 days ago about the histogram, I said, okay, you got to find the width of the rectangle. And what rectangles are we talking about? Look like this, this, and this. Like there's 3 rectangles. The width here is the same as the width there is the same as the width there.
Got you.
So I have to predetermine with a little formula like I did here, a number. It could be decimal, but a number, so that I add it to this to get me to the next hash mark.
2.
Okay, most people would do that. So we'll try. So I'll say try 2. Okay, so 1.2 plus 2 is what? 3.2. 3.2 plus 2 is 5.2. 5.2 plus 2, 7.2. Now, the question is this one going to be empty? Will there something go in here? One of the raw data?
Yes, because 1.2 is the lowest, so it'd be to the right.
Correct. Good. So that's not going to be empty. And then the highest is 5.6. You see 5.6 has some place to go. It's not going to go beyond. It worked. Width is 2. It worked. Yay. So then what you're going to do is say how many numbers between 1.2 and 3.1. Oh, okay. So how many numbers between 1.2 and 3.1? Okay, there's 1, 2, 3.1. 3, 3.1, 4. I think I count 4. So then you go like this. You say, okay, there's 1, 2, 3, 4. Like here, here, here. There's 4 numbers. Now 3.2 up to 5.1. 3.2 to 5.1. 3.2 to 5.1. 3.2 to 5.1. I think that's going to be empty. Right?
3.2 to 5.1.
Oh, my mistake. Okay, this is in between. My
Yeah.
mistake. 5.1. Yeah, it's that's there. Okay, sorry, not that one. This one here. This one here. So yeah, it looks like 4 of them. Yep. And finally, one more. I think there was only one more. Are there 9 altogether? 1, 2, 3, 4, 5, 6, 7. Yeah, 9. So one more.
Perfect. So
I recommend you do that instead of the instructions for all those problems you mentioned to me. And the same with all of you that are still here.
perfect. So instead of what it's asking for me in the book, this is what you want us to do.
Let's have you do that. You would be better use of your time and energy than trying to figure out this whole classes and boundaries. And I'll have to consider in the spring, should I get a stat, to eliminate or modify the question. So I just modified it for the 4 of you that are here today.
Perfect. Thank you. I really appreciate the help.
Yeah, you're welcome.
I just kind of wanted to ask where we'd use standard deviation in like the real world ever, besides, well, I guess like you'd use it in statistical analysis for like psychology and studies and stuff, but what's its actual function, I guess?
Without getting too deep, because you'll maybe in about 4, let's say 6 weeks, you're going to ask me that same question, and it'll be maybe a little clearer. Don't want to be too techno wordy. And let me put it this way. It's not a real life, but you might say, how about COVID? I mean, you can kind of put it towards COVID, because you'll start seeing bell-shaped curves, right? They talk about flattening the curve, and eventually they want it to go like this and go down to nothing. It might not ever get down to nothing because everybody's going to have some form of like the flu virus. Everybody's got a flu. You never make that go away. Never. But you don't want it to be like way up here. So it's all based on a normal, for most of this, normal, so I've used a word that you haven't even heard, a symmetric bell shape. Tests. If I were to grade on a test, on a curve, if I were to grade my whole course on a curve, okay, let's say from a previous semester, the average from my first test from the previous semester was 79. That was the average of the previous semester. Okay, now that's the mean. That's the important one. So that'll be my mu or X bar, but let's say it's my whole population of my one class. Then you calculate what's called the standard deviation through your calculator. And let's say that number turned out to be, and this was sigma, turned out to be squiggle 12. The number 12. Then what you guys are going to learn, and this will always be true for a bell-shaped curve, all you really need to do is go out 3 tick marks to the right and then 3 tick marks to the left. Now, you could go farther. I mean, we can go way out here beyond 79 or way down. These are test scores way down here. Like someone got a 1% because they just showed up and put the name and that was it. Those are called outliers, by the way, probably outliers. But let's say this was what we had, and I'm telling you ahead of time, but when we get to this chapter 6, everybody's going to hear me say it. All you need to do is go 3 markers to the right and 3 markers to the left. That's good enough. And you don't even know what good enough means yet, except right now, this distance right here is 12. And so is this distance. You're just subtracting 12 from here to go left, and you're adding 12 to go right. This is one standard deviation.
I guess I just wondered then, how does sample variance or like, well, population variance?
Variance, yeah, and maybe the end of the semester, end of the class, ask me about that. I rarely get to variance. Analysis of variance, it's called ANOVA. I'm supposed to, but I always run out of time. That's a topic that is used in probably, like you say, psychology, higher level psychology. You'll take probably another stat class beyond this if you really need to know that or use it. But standard deviation is the biggie, to start off with beginning statistics. So here's one, and there's, okay, so what do I do? Add 12 to this, and this would be what, 91? Yeah, 79 plus 12 is 91. Subtract 12 from this would be what, 67? Add another 12 to this one. See, that's the same standard deviation distance from marker to marker. This is what, 103, and add another one would be what, 115. Over here, subtract 12, so that's what, 55. Subtract 12 would be 43. Now, if I graded truly on a statistical curve and I stayed with that, then I know the number of C's that I give, the letter grade is predetermined. Doesn't matter how people did, because you are competing against others in the class. So I look at these numbers and I say, all right, who gets the C's? These guys in the middle right here, these are all C's. That means whoever got as low as 67 and someone who got a 90 or 91 actually get a C. What? Well, that's because the test was fairly easy, or it was like maybe it was all spread out or something like that. Yeah, these are all the C's, these are all the B's, and guess what? Nobody gets an A. The test was too easy. But it doesn't matter, because or maybe it wasn't too easy. No, actually it wasn't too easy. The test was maybe too hard because nobody got an A. Or people didn't understand it, and people didn't, nobody rose to the occasion. But the spread was too, this is D, sorry, D. These are the F's, and this is the A's. Nobody gets an A. That's why I don't do curves. But if you want to know what standard deviation, it kind of helps know from the average how far on, they call it standard distances, is each data value away from the average. Sorry,
so if you were grading on a curve, you would take all the scores and then find the mean and then the standard deviation, and that's how you'd make the curve?
That's right.
Okay.
That's right. And that's with all data that's quantitative. So it can't be categorical, it's got to be quantitative. That's why they're able to do with the COVID. You can see pictures online. You can see bell-shaped curves-ish being formed, because it's all numerical data that they're gathering.
All right, well, thank you.
I know that may not answer completely, but I think honestly, you're inquisitive and you've asked the question really early on. I think that it's going to be clear to you. And if it's not, you're going to ask me again, and we're going to have a deeper conversation about it towards the end of the semester.
All right. All right, we'll see you Monday.
Okay, all right. Okay, Jan and Maria, what questions do you guys have? Yeah, go ahead, Maria, first. Yeah, go.
Hi, okay. Hi, Jeff. I'm sorry I missed the last 2 classes. I sent you an email. Yeah, that was not a fun thing to do, driving through that.
Yeah.
I have a question on my okay, this is just a legit simple question. How do I erase one number on the calculator? Because when I was inputting the data, I screwed up on one number and I put clear and it erased my whole equation.
Let's say I want to get rid of the number 5.
Yeah.
So I'm going to try something. There's a delete button right here. I'm going to try that one first. DEL.
Yeah.
I'm going to try it. Can't remember if it just did it. Was there 2 5? I'm going to try it again and see if it made the 5 go away.
Okay.
It did. Yeah, that's all it does. It just put it on there and hit the delete button and it makes that 1 go away.
Okay, and it was more or less when we were doing the squared.
Oh.
Because I
Yeah,
tried.
you can't go backwards easily. So just retype it all back in and start it over again. Yeah.
Okay. And then another thing about the homework, is the assignment chart coinciding with your book or with our textbook?
Textbook. My book is a supplement to that as well. So today, the assignment schedule should have said, I thought I looked at it right today, 3-1 and 3-2.
And it 3-1 and 3-2, so the pages just have pound signs, or I guess.
Okay, so the homework is always out of your textbook.
Okay.
Always out of your textbook. It's not out of my packet at all. We just work through those in class if we can get to all of it.
Okay, so the pound signs are, I should look into chapter 3.1 in the textbook. That's where I'm confused.
Yep, gonna show you. I'm gonna get out of this, gonna get here, gonna click on that.
Hi, Jan.
Hi, Maria. How are you, honey?
I'm good. This
Okay,
is
do
my
you-
last class.
Do you see what I'm showing you?
Mm-hmm.
Okay, see right here, these are the 2 sections we're covering today, or I covered today.
Yeah, it doesn't have, you see how it says 118 and 141 on yours?
Yeah.
On the assignment page for the syllabus, it does not have that.
Oh, okay.
It's,
Okay, interesting. Maybe can you move over? See how I'm moving this thing over here? Maybe it's just too narrow. See, if I move this over, I'll move it over a little bit far. See, it's too narrow. So if you went up here and grabbed it like at the edge with the little crosshairs and pull it over, you might be able to see the page numbers.
Okay, I'm looking at, I didn't download the file. I'm looking at the view.
Say it one more time, because you've got a little back feed in your microphone.
I didn't download the file, but let me download it and try to edit it and see if
Good.
it fixes it.
Try that. Okay. While she's doing that, Jan, you have a question?
I was mostly being a fly on the wall and checking out other people's questions, but I did have one little question. The terminologies that are in the back of your booklet,
Yes.
are they listed in the order that we're going to occur them in the assignments? So we could basically draw a line at some point and go, these terms will be on this test.
Yes,
so on.
and actually in your cumulative. So as we go,
Yes,
then
of
you
course,
add more. There is 1, maybe 2 that is out of order. I think capital N, I threw it over there in the 30s, and really capital N, now you know it's population average. Population size. But other than that, I think all of them are in order.
Okay, we could always put an asterisk or something by that one when.
Okay, I'm going to tell you right now, the first test will be the first 11.
Okay.
And the first 11, and then the capital N, wherever that is.
Plus capital N. Okay. All right. I figure if I didn't have any questions, I still wanted to listen to what other people had.
So Maria, did it work for you this time when you opened it up?
Don't forget you're muted.
Oh, she was able to get it. Okay, that's good.
Okay, thank you. I know. I was like, I don't know where to go.
Yeah, good. Good question.
All right.
And your
Alex,
booklet does not have numbers on the pages.
no, it didn't. But just doing
That would
that.
help.
Yeah, I know. I'm sorry. I always, yeah, I'm almost ready to retire and I won't have to worry about it.
Did you decide where you're going to move to?
Tennessee.
Tennessee. My niece is in Baltimore and she's telling us to go and look out there. But I really think I'm just going to go further up north because that's
Yeah.
where there's more tribes.
Yes.
Or I could just live on the reservation, which I really don't want to. Like, because I would be in, they have subsidized housing, or you have a family plot that's passed down to you through, through ancestors. And our family plots are all spoken for. And then, but if I live in subsidized housing, which doesn't have a limit, I would only pay $35